Good morning, everyone, and welcome to this new series of webinars brought to you by the Cloud Solution Architects here at Ingram Micro Cloud. My name is Nigel Mullings, and I'm the lead Cloud Solutions Architect at Ingram Micro Cloud, and I focus on Microsoft's public cloud, Microsoft Azure. Today, I'm going to talk to you about how you can simplify your data protection needs while optimizing your costs using Microsoft Azure Backup. Although a lot of you may already know, let me first introduce you to the Azure Backup service. Azure Backup is an enterprise-class, zero-infrastructure solution native to Azure. It's simple, secure, and cost-effective while allowing large enterprises to manage their data's protection at scale across all their mission-critical workloads. Let's take a look at a high-level overview of the Azure Backup service architecture. Microsoft Azure Backup supports a variety of on-prem as well as Azure workloads, and Microsoft continues to expand support regularly. Backup data from these different data sources are moved securely to the data plane, also known as backup storage, which is an auto-scaling, reliable set of storage accounts managed by Azure Backup and isolated from customer tenants to provide additional security. Backup data can be stored in multiple tiers, starting with the snapshot tier, which can be stored in your own account, a standard tier to store all your backup data, and the recently added archive tier to store your long-term retention data, or LTR data. Finally, of course, there's the management layer, which allows you to configure, access, and manage backups at scale across your entire data protection estates, across vaults and across subscriptions. Let's take a closer look at how simple it is to onboard and manage Azure Backup before I give you an overview of the pricing. As the service is built into the Azure portal, it's a zero infrastructure backup solution, so there are no backup servers or storage required. It integrates with native workflows. You can create a virtual machine workflow to enable backup at the time of creation. And as you can see from the image over on the right hand side, there's a backup option for all Azure virtual machines to enable backup directly from the virtual machine in Azure, either in a new recovery services vault or an existing recovery services vault. Self-service restores can be managed from the virtual machine, from the vault, or from Backup Center. And again, I'll give you a quick overview of this in a short demo. Let's take a look at how Azure Backup pricing works. Azure Backup has two pricing components. The first one is protected instances, and it's like a management fee to enable and manage discovery, configuration, auto protection, policy, movement of data in a secure manner, and much more. The definition of a protected instance varies across workloads, and you can refer to the Microsoft pricing for Azure Backup for the specific details. The second component is the backup storage, which is a simple pay-as-you-go component. Let's take a look at some of these components, starting with protected instances. Protected instance is applicable for most workloads where data is moved into the vault, and it depends on the size of the data that you're protecting. In some cases, like Azure Files, where there's currently only one operational tier, also known as snapshot management, there's a flat fee. For newer workloads like disks, blobs, you discover, configure, and manage the operational tier backups for free. You only pay for the snapshots that are taken as part of the backups. Now let's look at the second component, the backup storage. With the recent changes, backup storage has two tiers, the standard tier and the archive tier. In the standard tier, you can choose the availability of your backup data across a variety of options. The default is GRS, and if you enable cross-region restore, or CRR, Microsoft will automatically upgrade it to RAGRS, or Read Access Geo-Redundant Storage. An important thing to understand about Azure Backup pricing is that there are no hidden or additional charges. This is a simple Price per gigabyte option without any additional transactions, zero application restore or egress charges. Also, the newly added archive tier will help you save costs for your long-term retention needs. I'll go into more detail on this in a later slide. Here's the summary of Azure Backup pricing. And as you can see, multiple workloads have been added in the last few months, and Microsoft continue to add newer features under the hood. So we've seen how Azure Backup pricing works. Let's take a closer look at some of the capabilities of the Azure Backup service. Looking at the diverse workloads of Azure Backup in a bit more detail, we'll see the range of support across three pillars: infrastructure, databases, and storage. If we drill down a bit deeper into those three pillars, the infrastructure, databases, and storage, we'll see that you can back up Azure virtual machines and Azure disks in the infrastructure pillars, SQL databases or SAP HANA in an Azure virtual machine in the databases pillar, and storage you can back up Azure files, Azure blobs, or you can use the Microsoft Azure Recovery Service or the Mars agent to back up on-prem servers to Azure. These are the tiers supported: the redundancy options, cross-region restore availability, private endpoint support, where the soft delete is supported, and where the customer managed keys are supported for each of the pillars. Backup Center provides a single unified management experience in Azure for enterprises to govern, monitor, operate, and analyze backups at scale. As such, it's consistent with Azure's native management experiences. Backup Center helps you govern your Azure environment to ensure that all your resources are compliant from a backup perspective. Below are some of the governance capabilities of Backup Center. Under Policy and Compliance, you can view and assign Azure policies for backup. You can view compliance of all resources on all the built-in Azure policies for backup. And you can view all data sources that haven't been configured for backup. Under Monitoring and Reporting lets you as a backup admin use Backup Center as a single pane of glass to monitor your jobs and backup inventory on a day-to-day basis. You can also use Backup Center to perform your regular backup operations, such as responding to on-demand backup requests, restoring backups, creating backup policies, and so on. You can also get visibility to those backup instances whose underlying VM database, etc., doesn't exist, and choose to remove unnecessary backups for machines which are no longer being used. You can use backup reports in Backup Center for analyzing historical trends and gaining deeper insights on your backups. Backup Center provides an interface to backup reports, which uses Azure Monitor logs and Azure workbooks. Backup Reports offers the following capabilities: allocating and forecasting of cloud storage consumed, auditing of backup policies and restores, identifying key trends at different levels of granularity, and gaining visibility and insights into cost optimization opportunities for your backups. In addition to the in-portal Backup Center experience, Azure Backup also supports various automation clients like PowerShell and command line interface, SDK and REST APIs for you to programmatically manage many of the key backup related operations. Here's a closer look at some of those reporting capabilities of Backup Center. To use backup reports, you need to configure your vaults to send diagnostics data to a log analytics workspace. And Microsoft provide a built-in Azure policy to enable you to configure diagnostic settings at scale for your vaults. These are the built-in policies for Azure Backup Center. And as you can see, there's a Azure Backup should be enabled for virtual machines policy, which will just obviously and make sure that any machine that policy is assigned to will be enabled for backup. This is the policy that you would configure your vault to use for reporting. So I mentioned that you need to configure your vault to use reporting, and you would essentially apply this policy to your vault, which says deploy diagnostic settings for recovery services vault to log analytics workspace for resource specific categories. So basically telling your vault to send backup data to a log analytics workspace, and then you can take advantage of the reporting capabilities. Let's take a look at some of the security capabilities of Azure Backup. Azure Backup provides built-in security, both to your data in transit and at rest. It lets you safeguard backup data against accidental deletions, ransomware, and rogue admins. You can use RBAC to grant fine-grained access to users for specific backup operations. You can use private endpoints to enable secure transfer of backups to backup storage. And never lose backups even if your source gets compromised, with backups stored in separate security and fault domains in Azure Backup Managed Storage accounts. You have full control over how you protect your backups with customer managed keys that are using 256-bit AES encryption. And you can use soft delete to prevent data loss or accidental deletion, with retention of backups for up to 14 days after deletion. And protect against ransomware by enabling multi-user authentication to add another layer of authorization for critical operations. All backup data is automatically encrypted when stored in the cloud using Azure Storage Encryption, which is 256-bit AES encryption, using either platform managed or customer managed keys. If I focus on costs for a second, I'll show you an effective way to save costs on your long-term retention data, taking advantage of the archive tier. The archive tier is supported for Azure VMs, SQL in an Azure VM, and Azure Database for PostgreSQL. And while tiering is automatic based on policy for PostgreSQL, Azure VMs and SQL on an Azure VM recovery points need to be moved manually to the archive tier. And below you can see the qualifying criteria for recovery points to be moved to the archive tier. Since backup storage, or the data plane of Azure Backup, is built on top of blobs, Azure blobs, some of the characteristics of blobs manifest in how they're used for backups. Looking at the table on the right, we know that the archive tier is a low-cost tier, but has high access costs when it comes to accessing the data. And you can see restores for the archive tier are charged per gigabyte for rehydration. So we move data less frequently into this tier compared to the standard tier, thereby increasing the recovery point objective. Along similar lines, the RTO, or recovery time objective, is also higher compared to the archive tier. All of this is to ensure customers can have the option to pay less for their long-term retention data, and hence the price is considerably cheaper. An important thing to understand is that even though the standard tier stores data as incrementals for virtual machine backups, they're converted into full backups when you move to the archive tier. This provides a self-contained and secure recovery point, thereby removing any additional points of failure when you want to restore your critical data. Let's have a closer look at this in action. So if I focus on the long-term retention data, let's define the long-term retention recovery point as those that have spent at least 90 days in the standard tier and have at least 180 days of retention left. Here's where the new archive tier becomes really helpful. Due to the low-cost nature of this new tier, you can reduce your cost considerably by moving your recovery points to the archive tier. At the top, you can see what a sample bill looks like for an existing usage of 1 terabyte. Let's see how it can change when you move your backup data to the archive tier. Before you move a long-term retention recovery point to the archive tier, the recovery point is converted from an incremental to a full copy by stitching together the first full copy and all other subsequent incrementals accruing to this recovery point. This ensures that once the data moves into the archive tier, it's self-contained and doesn't have any additional points of failure. The synthetic full copy is then moved to the archive tier. When doing so, any unique incremental bits held onto this recovery point will be held by the next recovery point to maintain the chain in the standard tier. Moving all your eligible long-term retention recovery points to the archive tier will convert them into full and independent copies. The retention for these recovery points will be retained from what was set in the policy for the standard tier, and any modification to the policy will also affect the recovery points that were moved to the archive tier. Moving data to the archive tier may increase the total amount of data in gigabytes, but because this tier is considerably cheaper, you'll be able to save costs using the feature. As you can see at the top right corner, the sample bill has now changed to a lower value once you move your recovery points to the archive tier. Okay, so here I am logged into Azure, and I've pinned Backup Center, a Recovery Services Vault, and a running virtual machine to my dashboard. What I want to show you is how to perform a backup and a restore of a file of a virtual machine from the actual VM. But before I do that, let's have a quick look at Backup Center. So this is the overview pane for Backup Center. Gives you a quick overview of the jobs and backup instances. You can see I've got one in progress, one completed, scheduled, and one on demand completed. Backing up that one VM, AD VM. And here are the Azure policies for backup that we talked about. And this is the policy for to enable reporting, send your diagnostics data to a log analytics workspace. And I've actually got that configured on one of my vaults. I can see which machines are still available for backup and not configured from Backup Center. And if I have a quick look at a vault, looking at backups from a vault, if I go into backup, I can see that I have status backup, a warning, one backup in progress. You can see my backup storage, how much I've used, and one item being backed up from the vault, which is an Azure virtual machine. Okay, so, and then from the virtual machine itself, so here's the virtual machine that I'm connected to. And let's say that I've got this really important stuff on this virtual machine, and I've got a really important document that must be kept forever. And then I have, let's say, a rogue employee decides to delete it and empty the recycle bin, and I can't get that back. So I'd want to restore it and get that file back. I can do that by either restoring the virtual machine or restoring a file from the virtual machine. So here I am on that ADVM. And if I go down to operations, I've got this backup tab, and I've got a bunch of snapshots that I took earlier. If I want to start a backup, I'll just hit backup now and say when I want to retain the backup until, and trigger the backup. The backup is now happening, and the disks off this virtual machine will be transferred to the vault. Restoring a file is as simple as either picking the restore file option or from the snapshot. This is the snapshot that I'm going to use. the one that I took at 8:57. I know it's got that file captured on it. That really important document is in this snapshot. So I can download this script under password, and then the script will mount the disks from the recovery point as local drives on my local machine. So if I have a look at my local machine, I've currently got 3 work drives not connected. I'm not on the VPN, I've just got my C drive. So this script will be ready to download shortly. Once it's ready to download, I'll copy the password and run the script on my local machine. There's the backup that got triggered. You can go to this backup, see that the backup's in progress. My download failed. Let's try that again. Try a different method. So from the virtual machine, back to the operations, select backup, and if I pick the snapshot this time, instead of file recovery, let's try it this way, and do file recovery, again, download executable. I just pause the video while that downloads. Okay, so now my script file's ready to download, so I just hit download. My file's there. Copy this password. It's going to ask me to input this password. Open the file. And this is just on my local machine. Once the password, so just paste it in. And it wants to do this in an admin console, so I'm just going to enter it again. And you can see it's fired up PowerShell as an administrator. And it can see an already connected session. Just say yes. Disconnects the old session and reconnects the new. Wait for a few seconds. Attach the volume. Let's have a look. There's the download. If I look now at my machine, I should have an additional drive. Yeah. So I've got this E drive. And here's my really important stuff. My file should be in there. So this is the drive attached to my local machine. Got my file back. I can just copy it up to the virtual machine and restore that way. I can now unmount the disks. It tells me to unmount the disks. I've got my data back. And then shortly this disk will be disconnected and the snapshot remains where it is. Just give that a minute to say it's been successfully unmounted. And then that's the restore complete. That was a high-level overview of Azure Backup, which I hope gives you some insight into how you can make significant cost savings using Backup Center and the archive tier for your long-term retention data. Thanks again everyone for taking the time out of your day to see this Azure Backup webinar. I do hope you found it useful. Please feel free to contact me with any questions or queries you have around Azure Backup or Azure in general, and I'd be happy to get back to you. Thanks again everyone, and enjoy the rest of your day.